Welcome to the second video of grade 12 work. So the outcome for this lesson is for you to be able to calculate the work done by a force which is acting on an object. Alright, so from the previous video we mentioned that for you to be able to identify the work which is done by forces, you firstly have to identify the forces that are acting on that object. Okay, so let's say, for example, you have an object of mass 5 kg as an example. Okay, so on that object there are forces which are acting on that object. It can be a gravitational force, it can be a normal force if there is a surface, it can be a frictional force if there is a rough surface, it can be applied force, and it can be your tension force if there is a strain. So of all those forces that I've mentioned, if the forces are acting on that object, some of those forces can do work and some of the forces do no work. Okay, and of those forces that do work, some of the forces do positive work and some of the forces do negative work. Okay, so now let us illustrate everything in terms of an example. Okay, so let's say we have an object of mass 5 kg at point A. And that object initially it is resting on a rough horizontal surface. So I said the surface is rough, meaning that we have friction. Okay, and then this object, or on this object, we have an applied force of 100 newtons acting on that object to the right. So now this object moves from point A to point B. Okay, so it means there is a displacement from point A to point B. So that is my delta x. Okay, and then instead of saying 100 newtons here, let's say this is my applied force. We know that it's 100 newtons. Okay, so that is my applied force. So now we want to find a way to calculate the work that is done by this force. But before we calculate the work done by this force, we have to understand whether the force is it doing work or not. Okay, so let us firstly identify all the forces that are acting on the object through a free body diagram. So on the lessons for forces, we have explained that you identify your forces using keywords, right? So in this case, I've said there is an object of mass 5 kg. The fact that there is mass, it means that we have gravitational force, which is pointing downwards. So that is the first force which is acting on your object. And the fact that it's resting on a horizontal surface, the fact that there is a surface and the object is in contact with the surface, then it means we have normal force. Okay, we have normal force which is acting perpendicular to the surface. So we have normal force which is acting perpendicular to the surface in that direction. And then the next force is your applied force. I have mentioned that there is an applied force which is applied to the right. Okay, so there is your applied force, and it was mentioned that the surface is rough. So it means if the surface is rough, we can conclude that we have what we call friction. Okay, or frictional force. But now the statement continues to say this object moved from point A to point B. So if the object was moving, then it means that this is kinetic friction. Okay, so the object moved from point A to point B. So for simplicity, I'll just put the direction of motion here, or the direction of the displacement, which is to the right. Okay, which is from point A to point B, which is to the right on this free body diagram. So on this free body diagram, we can see that in total there are 4 forces which are acting on that object. Okay, and in the previous video we said that some of the forces, they do work, and some of the forces, they do not do work. And of the forces that do work, some may do positive work and some may do negative work. Okay, and those conditions were explained in the previous lesson, but I'll also highlight them in this video. So now let us classify whether a force is doing work or not. Okay, so we said the condition is if the force is in the direction of the displacement, then this implies that it does positive work. So which force is in the direction of the displacement? We can see that applied force is in the direction of the displacement. It's going to do positive work. Okay, so we can see that your applied force does work, which is positive. And then the other condition was that if the force or the direction of the force opposes, if the direction of the force opposes the direction of the displacement, then it means it does negative work. So it means it takes out energy from that object, right? But if it's positive work, it puts energy into that object. Okay, so if we look at the free body diagram, you can see that your frictional force, it opposes the direction of the displacement. Okay, meaning that it does work, but it does negative work. Okay, so this does positive work and that does negative work. And then the last rule was if the forces are perpendicular to the direction, then it means they do no work. If the force is perpendicular to the direction of the displacement, then the force does no work. Okay, or you can say does not do work. So these are the 3 conditions. So we can see that if the direction of the displacement is to the right, we can see that the normal force is actually perpendicular to the direction of the displacement, then that does not do work. We can see in this case FG, since the object is moving to the right, FG does not do work because it's perpendicular. It's also perpendicular to the direction of the displacement. Okay, so that is how we identify whether forces are doing work or not. And then we identify whether the forces are doing positive or negative work based on the direction relative to the direction of the displacement or the direction of motion of the object. So we can see that in this case, there are two forces that are doing work, which is your applied force and your frictional force. But now, the outcome for this lesson, how can you calculate the work done by that force? So say you want to calculate the work done by the applied force, okay? You want to calculate the work done by the applied force, then that would be equal to that applied force multiplied by the displacement from A to B, okay? Multiplied by the displacement from A to B. So we take that force, which is your applied force, multiplied by the displacement. So but however, this force should be in the direction of this displacement, okay? So we add a cos theta to actually bring that force into the direction of the displacement, or that displacement into the direction of the applied force. But now, if we go to the free body diagram, we can see that the applied force is to the right, okay? And we can also see that the direction of the displacement is to the right. So between these two, there is a 0 degrees. Okay, so there's no deviation in terms of the direction. So there is a 0 degrees. So it means that our theta, if it's in the direction of the displacement, or if the force is in the direction of the displacement, then it means our theta is equals to 0. Okay, so this is how we calculate the work done by a force, but in this case is the applied force. So that would be the applied force multiplied by the displacement of the object, and then multiplied by cos of the angle between your applied force and the displacement. So it's very important to note that theta is between the force and your displacement. All right, so now we can see how we can calculate the work done by the applied force. Now let us calculate the work done by the frictional force, since we said frictional force does work also, and we also specified that it does negative work. So work done by the frictional force, that would be equals to the force, which is your kinetic friction, multiplied by the displacement. So it's the same concept. You always multiply your force and your displacement, cos the angle between your displacement and your force, right? So in this case, if you look at your displacement is to the right, okay? Your displacement is to the right, but however your force or your frictional force is to the left. So the angle between the two is actually 180. So it means in this case, your theta there would be equal to 180. Okay, and if you say cos theta, or if you say cos 180, then you would get -1, and that implies that the work which is done by a friction or by a frictional force would be negative. Okay, and then here, since we said the applied force is in the direction of the displacement, the angle between them is 0 degrees, then we can say that if this is cos 0, then that would be 1, which is +1. Then it means that the work done by the applied force, or the work done by the force which is in the direction of the displacement, then that would be positive. Okay, so now it's important to know that it's not always that your applied force does positive work. It's possible that your applied force is applied to the left in this case. So let's say there's another applied force there. So there's this applied force which is pointing to the right, and there's this applied force which is pointing to the left, right? So we can see that this applied force pointing to the left, it does work because it's parallel to the direction of motion, because the motion or the object moved from point A to point B, right? So that is acting, it's actually acting in the same direction as your friction, if we can add it on the free body diagram here. So if you were to calculate the work done by this applied force, then it would be negative because it's opposing the direction of the displacement or the direction of motion of the object. So it's possible that applied force does negative work. It depends on the direction where it's acting. So now let us have a simple practical example. So let's say we have an object of 10 kg, and that object of 10 kg moved from point A to point B, and the distance between point A and point B is 5 meters, for example. Okay, so this object is on a smooth surface. So if it's a smooth surface, then it means we have no friction. Okay, and an applied force of 10 newtons is applied on the object as the object moves from point A to point B. Okay, so now firstly, how many forces are acting on the object? So we identify that by making use of a free body diagram. Okay, so the free body diagram would have your gravitational force, and the main reason why we have your gravitational force is because we said we have mass of 10 kg. The moment you have mass, you have a gravitational force, right? And then the fact that we have a surface and the surface is horizontal, then you have your normal force in that direction. Okay, and then the third force, you have your applied force, which is 10 newtons as given in the diagram, and they specified that the surface is smooth, right? If the surface is smooth, then it means that there is no friction. So I'm not going to draw friction on the free body diagram because it's not there. So now we have identified all the forces that are acting on the object. So question is, where is the object going? What is the directional, or what is the displacement? What is the direction of the displacement? From A to B, we can see that the direction is to the right. From A to B is to the right. So that is the direction of the displacement. Okay. So let us identify which forces do work and which forces do not do work. And if those forces do work, is it positive work or negative work? Okay. So now let's start with the applied force. We can see that the applied force is in the same direction, or the applied force is parallel to the direction of the displacement. Then this one, it does work. Okay, and then FG is perpendicular to the direction of the displacement, then that does not do work. Same applies to the normal force. It's perpendicular to the direction of the displacement, then that does not do work. Okay, so now let us go to the applied force. The applied force is the only force that does work in this case. Now, can we calculate the work which is done by that applied force? So the work done by the applied force is the applied force, which is the force multiplied by the displacement, cos of the angle between the force and the direction of the displacement. Okay, so the work done by that applied force is equal to the magnitude of the applied force is given as 10, and the magnitude of the displacement in this case is given as 5 meters. Okay, and then cos the angle between your applied force and the displacement, we can see that they are pointing in the same direction, meaning that the angle between them is 0 degrees. And if you punch this on a calculator, then you would get 50. And now it's important to note that work is the same as energy, okay? So it's energy which is transferred into or out of the object, okay? So now, if work is the same as energy, then the units of work is joules, and this is a scalar quantity, it does not have direction, okay? So we can see that this is positive 50, meaning that this applied force is doing positive work on that object, or on that object of 10 kg, while moving it from point A to point B. It does positive work of 50 joules. Okay. So now let us clarify the definition of work. So now if you want to define work, we would define it using the formula that we use to calculate work, which is the product of the force and the displacement in the direction of the force. So it means that that displacement, it must be in the direction of the force for you to get that work. Okay. So now the definition of work. So now in terms of understanding, we said that work is the energy which is transferred into the object if it's positive work, or out of the object if it's negative work, right? But in terms of defining it now, if they say define the term work, we define the term work in terms of the formula that we use to calculate work. Okay. So in terms of the definition, work is the product of the force. We can see from the formula that is this force multiplied by the displacement. Okay. So it's the product of the force and displacement in the direction of the force. So this cos theta is actually taking the displacement to the direction of the force. So it's in the direction of the force. So now we have achieved the outcome for this lesson. So the outcome for this lesson was to actually be able to calculate the work done by a force, and we do that by using a formula which says work is equal to the force multiplied by the displacement multiplied by cos theta.